Okay, so when merging neuroscience-based applications with musculoskeletal rehab, we need to understand the basics of neurology. Now, when we're looking at things from a neurological perspective, we need to understand that sensory information that's gathered from our environment, from our tissues, from our muscles, from our joints, from our nerves, will be interpreted by the nervous system in a certain way, which we'll talk about, and that will deliver a certain kind of motor output into our body for movement to occur. Okay? Now, we need to understand what happens during this layer. So whenever we, as practitioners, as health and rehab practitioners, we are loading someone's system, we are delivering an exercise, we're delivering manual therapy, we are essentially stressing their system. Now, stress tends to be demonized quite a bit when it comes to movement and when it comes to rehab. But what we need to step back and understand is that it's not about the stress acting on the system. It's about the way the system is responding to the stress. And that's a very, very important concept to understand, because everything that acts on our body is stressing our body. But what happens is when that sensory information gathered through that stress, so when you put pressure through someone's skin, when you load someone's muscles, when you load someone's joints with a certain exercise, you are loading their system, you are delivering feedback up to the nervous system. And when that feedback gets up to the nervous system has to ask itself two questions. Basically, those questions are, is the information safe? Or is it dangerous? Is it a threat to my survival? That's fundamentally what we need to understand. Is the information that we're delivering to the nervous system safe, or is it not? And as practitioners, we deliver that information through muscles, nerves, and joints. We need to understand that humans are multi-sensory creatures. We don't just gather information from muscles and joints, but we also gather information from nerves, from the eyes, from the vestibular system. All this information has to be interpreted by the nervous system to understand if it's safe or if it's not. Now, if that information is granted or if it's deemed unsafe, what do you think might happen? If the nervous system deems information is unsafe, it might express a protective output. And protection might come in the form of excessive tension, excessive tone, perhaps pain or discomfort. If the information is deemed as safe, we're just going to carry on moving like we normally do. Okay? Now, this can be very, very important to consider in real-world movement scenarios where it becomes a little bit more complex. And the easiest way to kind of give you this information and to share this information to you is by understanding things from a pain standpoint. What happens when we express pain? So, for example, let's say I'm going for a jog. And when I'm going for a jog, let's say I step on a stone and I roll over my ankle. Now, in that moment, when I roll over my ankle, what has to happen is my nervous system has to gather information from the stretch around the ligaments and the tissues around my ankle. And depending on the severity of the jolt, if it's a strong jolt and if it's a strong stretch of those tissues, that sensory information is going to drive back up to the nervous system. The nervous system is probably going to interpret that as something dangerous, something threatening, because it was a quick and a sharp jolt. So what is it going to do? It's probably going to express a painful output. Pain. Protect you. Pain is a form of protection because it ultimately doesn't want you to continue running on a potentially damaged ankle. So it's good. It's good in the short term. Obviously, we don't want the individual to still be in pain 1 month, 2 months, 3 months down the road, depending on what kind of injury they sustained. But that pain is essentially a protective output to stop you from running. Okay? Now, for example, let's say you were going for a similar run. You rolled over your ankle, but now you see a bear chasing you from the corner of your eye. Now your nervous system has two pieces of information to process, both the information from the ankle, but also the information from the bear. What do you think it's going to interpret as more dangerous, more threatening? It's probably going to interpret the information from the bear as more threatening, so it's probably going to modulate its output to get you away from the bigger source of threat, the bigger danger, which is the bear. And so the nervous system is constantly doing this, is constantly weighing up sensory information, understanding what's dangerous, what's not, what do I have to do to express protection, to keep you alive, to keep you safe. So it all comes back to safety. How can we as health and rehab practitioners prove to the nervous system that we ultimately have the ability to protect our own bodies? In the next video segment, we're going to go through more of a detailed understanding of what happens when the nervous system loses the ability to trust that your body has the ability to protect itself, because the nervous system is constantly gathering information and updating its estimation of your body's capacity. And if your nervous system doesn't trust that you possess the capacity, the qualities to express protection, then what will happen is the central nervous system will have to step to the forefront and express pain, express tension. So from an IKN perspective, what we will teach you how to do in these courses is we will teach you to identify the qualities throughout the upper limb, throughout the lower limb, throughout the midline that prove to the nervous system that we have the ability to protect ourselves and handle stress acting on our system, and merge these strategies with more local techniques to really improve the robustness of the individual. Because when we say robustness, when we're trying to build a robust individual, we are trying to build and facilitate a person that can handle much more stress to the point where the nervous system will not need to express pain. When we're trying to have an influence on pain from a rehab or a treatment standpoint, it's not a case where we're trying to just fix pain or decrease pain, but what we need to try and do is we need to try and create an environment where pain is not necessary as a protective response. So instead of focusing on the motor output, what we need to do is we need to step back and understand the quality of the sensory input. And so we need to have a look at the load capacity of the muscles, the joints, and the nerves. It all comes back to these three sources of input, but we need to look at it from a neurological perspective. The way the muscles are distributed throughout our body is very, very different. The way our joints are distributed throughout our body is very, very different. The way the nervous system controls these body structures is very, very different. To give you a simple idea, when you look at the midline of our body, our trunk, versus our extremities, you can see an awful lot more muscle mass around the midline of our body versus the most distal part of our extremities. You typically don't see people with a lot of muscle mass around their hands, but you typically see more muscle mass proximally around the shoulder, around the midline. And there's a reason for that, and the reason is energy efficiency. Because our midline needs to be approached in a different manner versus our limbs. And so when we're looking at movement, when we're looking at improving the pain and movement related issues in an individual that we're working with, what we have to do is we have to understand what allows the midline to be an effective midline. So if we're looking at neck pain, if we're looking at back pain, if we're looking at shoulder pain, spinal pain, we need to step back and understand the main qualities that the midline needs to be able to express to be effective, to be efficient. The same thing happens for the upper limb and the lower limb. We need to understand what does the upper limb, what does the lower limb need to express to be an effective upper limb or lower limb. And then we can merge these strategies, these global strategies, with our local based techniques. And if we can merge global strategies with local strategies, then we can have much more influence over an individual's pain experience. We can create an environment where pain is no longer necessary for protection. But it all comes back to understanding this three-step process. Sensory information goes to the nervous system. The nervous system has to ask, is it safe or is it dangerous? If it's safe, it'll continue carrying out the movement that we want to carry out. If it's deemed dangerous, it may express a protective response. So instead of affecting here, we need to affect here. We need to deliver better quality sensory feedback. So ultimately the nervous system can make better decisions about the information that we're gathering from our body. And so it doesn't feel the need to express pain. So we affect the sensory systems to ultimately affect the motor output. We don't affect the motor output directly. We always affect the sensory feedback to have an influence on the motor output. So if we can shift our awareness towards delivering better quality feedback, better quality sensory feedback to our brain from our muscles, nerves and joints, then we can ultimately create an environment where pain is no longer necessary. And we're going to give you some specific examples from a lower limb standpoint in some of the upcoming segments.